Good morning students, welcome to physics practical class. Up to now we have discussed two experiments. Both are used to measure the length. First one, vernier calipers, is used to measure the diameter and as well as length. Second experiment, screw gauge, which is used to measure the thickness or diameter of the given object. First one, vernier calipers can measure a minimum reading of 0.01 centimeters, and the second experiment, screw gauge, can measure the minimum reading of 0.01 millimeters. Now we are going to study experiment number 3. What is the importance of this experiment? In previous two experiments we calculated the thickness and as well as the length of given object. In today's experiment we are going to measure the radius of curvature of given curved surface. So it is with ordinary apparatus like scale or screw gauge or vernier calipers, it is very difficult to measure the radius of curvature of given surface. So to measure this radius of curvature we need a separate apparatus. So today we are going to study about that apparatus, and the name of that apparatus is spherometer. So without wasting much time, let us go through this experiment of this spherometer and how it is used to measure this radius of curvature. How this spherometer appears. So let us see the shape of this spherometer. So this is the design of this spherometer. Here also we are having two types of scales. First one is pitch scale, which is provided vertically, and the second one is circular scale, which is also called as head scale. So which is divided into 100 equal divisions. So this is a head scale and this is pitch scale, and here these three legs are provided with uniform distance between them. If you measure the distance between any two legs, that gives L value. So I will show you this equation. Second one, whatever the object whose radius of curvature is to be measured, that can be placed at the middle of this part. So at the center of this spherometer, so that the curved part will make this circular scale to move up, and we can measure the reading, how much this disc is moved up. Basing on that we can measure the reading. So let us go through this video or the procedure how this spherometer is used to measure the radius of curvature. This is the experimental procedure shared to you. So here the radius of curvature of the given surface can be measured using this equation L square by 6h plus h by 2. As I told, L is the distance between the legs, average distance between any two legs, and height is the h is the difference between the readings of the glass plate and the curved surface. So by using this equation we can find out the radius of this curvature of the given surface. Here also we are having a least count. As I told, pitch scale reading which we can get from the vertical scale of this spherometer, and head scale reading which we can get from the circular scale, and least count can be calculated for this spherometer, and we can use this least count for finding out the radius of curvature. So to calculate the least count, the same procedure will be applied like how we applied for screw gauge. So pitch of the screw, here pitch is equal to number of divisions moved on the pitch scale by number of rotations. Usually when we try to rotate that disc, it will move one division on the pitch scale, and number of rotations will be 1. So the divisions moved will be 1, and for that movement of that divisions we are making one rotation. So pitch of this spherometer is 1. and least count is equal to pitch by number of divisions on the head scale. So which is 1 by 100, 0.01 millimeters. So whatever the readings we are measuring from this spherometer will be in millimeters. So after measuring this least count, go through the procedure which is given in the lab manual given to you. So precautions and sources of error. Now let us go through this animation video, how we can measure this radius of curvature. So this is the video which I am going to show to measure this radius of curvature. Using this spherometer, not only we can measure the radius of curvature, but we can also measure this thickness of the given glass plate. So but that is not given in our portion, but we can measure that also using this spherometer. So what are the different materials required for this measurement? Are first one a white paper, second one spherometer, third one glass plate whose thickness is to be measured, and fourth one the glass plate which is having curved surface. Let us watch the video how we can measure this curvature. First of all, the spherometer should be placed on the glass plate and all the three legs should be placed at one particular point. All the three legs should be faced perfectly horizontal surface. Now we are going to see the procedure. Observe this pitch of this scale. This is screw and the distance between the three legs. First of all, we are going to find out the least count. Please observe the procedure clearly as I told. So this is the base reading and we are rotating 4 rotations. So rotations done by us are 4 and the displacement of that circular disc will be 4. So distance moved is 4 millimeters and 1 millimeter is the pitch. So total least count will be 1 by 100 millimeters. So that is the given point. Now place the spherometer on the perfect horizontal surface and mark the positions of the three legs, and we can measure the distance between the legs, the average distance between the legs by assuming AB, AC and BC, and average distance we will get here is 4 centimeters, which is 40 millimeters. Usually the distance will be 40 millimeters. Now we are going to see the spherical surface. Place the curved part on the horizontal surface and above that place this spherometer and gently make this circular disc to touch that curved surface. We can check whether this leg is touching the base or not by placing that paper below that. Once if it is touching, the paper won't go into that fourth leg. So we can measure the head scale value. It is 5 divisions. Note down the reading as 5. Now remove the and place this on the perfect horizontal surface and rotate again so that it is touching that base, and again we can check with the help of the paper whether that fourth leg is whether that circular disc is touching the base or not. So once it is touching, we can measure the number of rotations made by this circular disc to touch that base. So here number of the head scale division is shown as 50, and here the distance moved to touch that base is 0, 1 and 2. So note down these two readings properly. So here we can put these values in the tabular form. It is 50, and rotations done, total rotations done are actually it is shown here 3, but few readings are pending, few rotations are pending. So 3 it is not completed, so we can consider that as 2, and remaining divisions we can calculate by using this equation. Here we can consider 2 completed rotations and remaining incomplete rotations, which are 55. So by using this equation we get 55, 100 plus A minus B. So here it is shown 3 completed rotations, but actually 2 rotations are completed and the remaining 55 rotations are pending. So we have to consider the reading like that. So if you remember this properly, you can remember number of rotations completed are 3, and final reading will be 3 minus 1, which is 2 point this 100 plus A minus B. So 100 plus A is 105 minus B is 50. So 105 minus 50, which is 55. So total reading will be 2.55. That is the rough reading of that height attained by that curved surface. So I hope you understood this one. Once again I am explaining. Number of rotations completed, here it is shown 3. Usually we have to consider 2 because some part will be incomplete. So we can consider that as 2, and how much it is incomplete, that we can calculate by using this equation. So 100 plus A minus B. So we will get 55. So the total reading of this spherometer for the curved surface will be 2.55. After attaining this height 2.55, we can use L square by 6h plus h by 2 formula, and we can calculate the radius of curvature. In that procedure, if you proceed, you will get this radius of curvature as 105.85 millimeters. So I hope you understood the procedure. So let us go through this simulation video to find out this radius of given surface, curved surface, using this spherometer. This is the simulation video which we are going to see. So first of all, as I told, we have to select the spherical surface whose radius of curvature is to be calculated. So I selected that one, and now I am rotating this disc so that the base will touch the curved surface. Here distance between the two legs is already given, it is 40 millimeters, and the least count is 0.01 millimeters. So let us start the procedure. So by touching this arrow symbol, the spherometer will go down and it will touch the base. Once if it touch the base, you will get a shade here. That shaded part indicates that this circular disc is touching the base. Now measure the rotations. Now measure the head scale reading. So head scale reading will be 0 and 1. For me, this head scale reading I can able to see 1. Now we can remove this spherical surface, and we have to measure the readings on the plane horizontal surface. So you can select once again the spherical surface so that it won't be there. Now we can again rotate this disc so that this disc should touch this base. So before going to rotate this one, please carefully observe what is the reading shown by this vertical scale or pitch scale. So by observing this reference, we can easily find out how many rotations this disc is making to touch the base. How many rotations the disc is making to touch this base. So please clearly observe this pitch scale reading, and just I am trying to rotate this one. We can measure in another way also. Here I can able to see 1. Now if I start rotating, half rotation will be happened. So if I press 2 times this arrow symbol, 1 rotation will be completed. Like that also we can measure. Any one procedure we can apply. So which one is easy, you can proceed in that manner. So I am proceeding here by assuming this rotations. Here I can get 1. Now I am pressing this arrow symbol carefully, so that for 1 pressing it will go 50 divisions. Here it got displaced, so I am rotating completely. So that it can touch the base. We have to press this arrow symbol till we have to get that black color shade. That black color shade indicates that the disc is touching the base. Here I am not getting that one, so I am pressing continuously. Here if you see, after making this leg disc to touch the base, here I am getting a black color shade, so I can confirm that this disc is touching the base. So to make this disc to touch the base, I have rotated almost 4 divisions. So I can consider 3 divisions plus remaining 100 minus 100 plus 1 means 101 minus this 81. So 101 minus 81. So 4 millimeters it is displaced. In that I am subtracting 1. So it will be 3 plus 100 plus 100 plus 1. Previously we got 1. So it will be 101 minus 81. 101 minus 81 is 20. So 3 plus 0.2. After considering that least count, we will get 0.2. So 20 into 0.01, which is 0.2. So total reading will be 3.2 millimeters. So the height of the curved surface will be 3.2 millimeters. Now use that equation L square by 6h plus h by 2, and after getting that value, substitute that value here, and we can cross check the result. So let me do the calculation and type the result here. I calculated the radius of curvature from external source, and I got the value as 84.93 millimeters. So let us cross check the value once. So that is the value which we have to get for this spherometer. So radius of curvature of given curved surface which we are using is 84.93. So that is the result of this experiment. So I hope you understood today's experiment, spherometer. If you have any doubt, we can do this experiment in online session also. So at the time you can clarify your doubts. Before that, please go through the procedure and try to do these experiments using this simulation. So next week I will come up with another experiment. Till then, take care. Thank you.